Hello everyone, welcome to Homework Hell. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of cross product. So as per the problem, verify that rule P cross Q plus R is equal to P cross Q plus P cross R is true for the following vectors. So we are given the three vectors PQR and we have to prove that this rule is true for these three given vectors. So let's start with the left side. So we'll find the result of the expression P cross parentheses Q plus R. The first step is to add the vectors in the parentheses. So we'll find the sum of vectors Q and R. So we'll add the given vectors. So we can add their x, y, and z components. So 1 plus negative 1 is 0, 2 plus 1 is 3, 7 plus 0 is 7. So this is the vector for q plus r. Now we'll do the cross product for p and this vector we got for the sum of q and r. So we have to do this cross product. So for that, we'll stack the y, z, x and y components of these two vectors. So in the first vector, the y component is negative 2, z component is 4, x component is 1, y component is negative 2. In the second vector, the y component is 3, z component is 7, x component is 0, and y component is 3. Now we can find the x component of the cross product vector. So for that, we'll cross multiply the y and the z component. So we start from the top left and go across in the downward direction. So we'll multiply negative 2 by 7. And from that, we subtract the product of 3 and 4. So we always go from top across to the bottom and then from bottom across to the top. The negative 2 times 7 is negative 14, negative 12. So I got negative 26. So this is the x component of the cross product. Now we can find the y component. So we'll do the cross multiplication. So the y component is negative 7. Now we can find the z component. So z is equal to 3. So the result we get for the left side of the rule equation is the vector Now we have to check the result we get from the right side. We have to do P cross Q plus P cross R. So let's start with P cross Q. So we should stack the y, z, x and y components of these two vectors. Now we can do the cross multiplication. So let's start with the x component. So we start with -2 times 7. Now we can find the y component. Now we can find the z component for the cross product vector. So the cross product of P and Q is vector. So next we can find the cross product of vectors P and R. So now we can stack the y, z, x and y components of these two vectors. Now we can calculate the x component of the cross product of these two vectors. So we should cross multiply the y and z components. Now we can calculate the y component. So I get y equals -4. Now we can calculate the z component. So we can cross multiply the x and y components. So I got z equals -1. So that means the vector that we get from this cross product is -4, -4, -1. Now we can add the vectors we got from P cross Q and P cross R. So from P cross Q we got and from P cross R we got. Now we can add these vectors. So we should add their x, y and z components. So negative 22 plus negative 4 is equal to negative 26. Negative 3 plus negative 4 is equal to negative 7. And 4 plus negative 1 is equal to 3. So this is the vector we get from the expression on the right side of the given rule equation, and it is equal to the vector we got from the expression on the left side of the rule equation. So this proves that the rule is true for the given vectors p, q, and r. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.